Hello everyone. In this session, we are going to discuss about load balancer. As in previous session, we discussed about firewalls, different type of firewall, different options available with AWS, Azure, and GCP. Apart from that, we discuss about the IP addressing. We discuss private IP, public IP, elastic IP, including CIDR block and subnetting. Okay. So now we are going to discuss about load balancer. As the name indicates, to balance the load within the network. A load balancer distribute incoming network or application traffic across multiple servers to ensure no single server become overwhelmed or overloaded. For example, what we can say, we have multiple server here, multiple either application server or network load balance network any server. Okay. So what it can be, if we have a load balancer here, what happened? Any of the incoming traffic from the network via internet or any application. So to distribute all that incoming traffic across multiple servers equally. Why? First, load balancing. So single server will not be overwhelmed or overloaded with the incoming requests. Second, failover. How the failover? If one of the server goes down in any case, it immediately starts sending the traffic to the remaining servers. Got the point? So that is the prime purpose of a load balancer in a network. And nowadays the traffic is going on increasing. Network utilization going on increasing. So it's mandatory to have a load balancer in your network. Always mandatory to have a load balancer in your network. Next, type of load balancer. Type of load balancer. One is a layer 4, that is a transport layer. Means you should be little bit familiar about the OSI model. Little bit about the OSI model. So layer 4 is the transport layer in a OSI model. Which protocol work there? That is a TCP and UDP. So transport layer, or also called the network load balancer in AWS, it's called network load balancer. Balance the traffic based on IP address and port number. That is the network layer load, network load balancer. Second is the application layer load balancer. Application load balancer. And it is in the layer 7. Layer 7 means application layer. Make routing decision based on content like HTTPS header and path and cookies. The main protocol, if you know, the protocol that work at the application is HTTP and HTTPS and many more also. But right now we are just considering HTTP and HTTPS. So mainly there are many other also load balancer. One is a gateway also. But right now we are mainly focus on this particular application layer and transport layer load balancer. Next, what are the benefits? What is the benefit we get by using the load balancer? As already discussed, high availability and reliability. Failover clustering, failover. Okay. High availability, how is available? There are multiple server available. Load balancer is working here. So what's happening? Whatever the traffic is coming here via internet, it is equally distributed It's equally distributing that traffic to the all the servers. So what does it mean? A single server is not going to be overloaded. You are properly utilizing the resources available to you. So highly available. If single server become overloaded, then what happened? Maybe not able to reply the users properly because its capacity of a server suppose have the 100 queries and suddenly the queries come of 200, 500 and 10,000. So single server will not able to do that. So not available that time, or servers start denying the requests coming to that. So load balancer taking care for that, rather than forwarding the traffic to a single server, it distribute the traffic across multiple servers. Reliability, naturally, if one of the server goes down, still other servers are available to reply the client. To reply the client. In this way, main benefit, availability and reliability. Second option is the scalability, horizontal scalability. In our real environment, wherever we implementing the NLB, it always integrated with, you can say, one of that is known as the ASG. That is known as the ASG. What is ASG? Auto scaling group. Auto scaling group. Clear? So in case your NLB analyze that server is going to be overload, it inform to the auto scaling group. Auto scaling group automatically add more servers here as per the requirement. Or in case server is not much, server is okay, load is okay there on the server, it can also scale in that servers, mean can remove as per your requirement. So this combination of network load balancer or any application or network load balancer with auto scaling group, first make it available, reliable, scalable as well as cost saving also. We are getting all the targets that we want to achieve from a cloud when we are moving our data center from on-prem to cloud. So the combination of load balancer with auto scaling group fulfill our all the targets. Next, health check to reroute the traffic from failed instance. I already discussed that. If any one of the instance fail, what the load balancer is doing, it keeps checking the health of all the instances there in the network. So if it found that particular server is not responding in time when it is sending the health check packets there, so what it do, rather than sending the traffic to this unhealthy server, it start forwarding the traffic to other healthy servers in the network, other healthy instance into the network. Clear? And also the offloading SSL encryption and termination. So that is a thing, that is a benefit is the of the load balancer. So let's check how we can do that. We are on the console. I think everybody is familiar with this console. So for the load balancer, we need to go to again compute. In compute, we have to go to EC2. Okay. In EC2, you will find one option here, that is the load balancing option. On the left side, you will find load balancing option. What we have to do here, first we need to create a group, then we have to configure the load balancer. So if you go to the group, here I have to define no group here. So create target group. How you want, what you want in your group? Some instances, some IP address range, some lambda function range, or any application load balancer. So right now, suppose I'm giving the option. If instance, we can give any name. Okay, any name here. Which protocol you want to use? HTTP, HTTPS, TCP, UDP, and you can see here option TCP, UDP both, or GNAV. That is a gateway load balancer. Okay, leave it. So I just want to demo, not going to do which VPC you want to choose here, you can choose. And in this way, you can create a, now it will, no instances added here. So in this way, you can add the multiple instance here in this particular group. So after doing this, our next step is the load balancer option. To create a load balancer here. What we do in the load balancer? Right now we don't have any load balancer here. So what we do? Create load balancer. Now you can see here, we have the option to configure either application load balancer, either to configure a network load balancer, and third option is the gateway load balancer. If you go into detail, I have told in the theory, application load balancer work on the protocol HTTP and HTTPS. Choose an application load balancer when you need to flexible feature set your application with HTTP or HTTPS traffic. Application load balancer provide advanced routing and visibility feature target at application architecture, including a microservice. There can be the containers also. Okay. If we talk about network load balancer, at the transport layer, you can see here the protocol working is TCP and UDP, including the TLS. Choose network load balancer when you need ultra high performance. TLS offering at offloading at scale. Centralized certificate deployment, support for UDP, for static IP address for the application, everything it is supporting. Operating at the connection level, network load balancer are capable to handle millions of requests per second securely or maintaining ultra low latency there. One more thing that I want to add, that if there is one load balancer, either application or network load balancer, server here, instance here, and that is controlling the traffic movement or traffic balancing. So like if we configure application load balancer, traffic is coming here on the load balancer. It check for HTTP and HTTPS header. So if the traffic belong to HTTP and HTTPS, then this load balancer take care for that and distribute on the server equally, do the load balancing. But if traffic coming there is not HTTP or HTTPS based traffic, then what it can do? Some traffic comes here that is not HTTP or HTTPS. is put directly on the ping, then this load balancer will not entertain that traffic. It bypass and traffic directly go to the instance. It only take care, any load balancer will only take care for traffic like HTTP and HTTPS in case of application load balancer, and TCP UDP traffic in case of network load balancer. And third one, most commonly used in application and network load balancer. What is the gateway load balancer? You can check here. Choose the application gateway load balancer when you need to deploy and manage fleet of third-party virtual application that support GenAV. This application enable you to deploy security, competency and compliances and policy control. So from here, now you can configure your load balancer. So we discuss here about application load balancer. I have shown you in the console how we can do that. So next we have to discuss here, that is the DNS routing. Everybody, I hope everybody heard about the DNS. What is the role of DNS? DNS is a domain name system. Routing translate domain name like this name to the IP address. The purpose of the DNS in your network is to resolve name to IP. We are writing something like xyz.com, that is a user-friendly name. Communication happens on the base of IP. But in real scenario, you have millions of websites, so not possible to keep remember the IP of everyone. So that in that case, DNS help us to resolve name to IP. DNS routing policies determine how traffic is directed when user resolved a domain. So we can set different routing policies there in DNS, how to handle the traffic, how to direct the traffic when a user resolves a domain. So these are different type of routing. One is a simple routing, one is a weighted routing, latency based routing, geolocation routing, failover routing and multi-value answer routing. Direct, simple routing, direct all the traffic to one IP or endpoint. You can say one-to-one, where we configure to forward the traffic only one IP, or we configure some endpoint. That's a simple routing. Weighted routing, split traffic based on the percentage. 20% traffic should go on this route, and 30% go on this route, and 50% go via this route, like this. Latency. Then we talk about the latency based routing. Means send user to server with a low latency. Low latency means getting response faster. There can be the n number reason behind that. Like there can be the network congestion, there can be the server loading. So from where we are getting the lower latency, we send the user traffic to that site. Next is the geolocation routing. Next is the geolocation routing. Router used based on their geographical location. Means like you can simply say na, searching www.google.in means in India, get lower latency or get faster, so closer to my geographic location rather than searching geo.co.uk or any other location. So it forwards the traffic based on geographic location. Failover routing, in case primary route fail, to reroute the traffic on another available server. Multi-value answer routing, return multiple IPs and relies on the client side retry, where we're getting the multiple IP in return. So we depend on the client side. So AWS Route 53 support all these policies. Clear? So how they work together? DNS and load balancer, how work together? DNS resolve the domain to a load balancer IP. It does not forward the traffic or resolve the name directly of a server. It resolves the IP of a domain server by load balancer. It resolves the IP of load balancer. Then load balancer forward the request to one of the backend server based on the load, health and rules. For example, user visit this site, DNS Route 50 resolve the application load balancer, can be the NLB. Then NLB or ALB distribute healthy EC2 instances. Simple process. I think nothing complicated so much to understand. Who have the little knowledge of DNS. This is the routing. You can see the complete map. Routing. User send a request to the DNS. On the base of routing, it resolves the IP of load balancer. Then load balancer distribute that particular traffic to the different server registered under that load balancer. All clear? Everything is simple. So basic DNS hosting available on AWS Route 53 Azure DNS, but not available with the cloud. Geo-based location. So these are all the different comparisons. What Route 53 in AWS, what Azure DNS, and what the Google providing there. So clear everything about what we discussed in the today's session. We discuss about load balancer, type of load balancer, and also see the practical demonstration of that. Then we discuss about DNS routing and routing policies. So hope you learn from this. See you in the next video with next topic. Till then, thank you very much.